First, live, local. This is Fox 12 Now.
Hello, everyone. This is Fox 12 Now. I'm Greg Nibbler. Thank you very much for joining us. We are live streaming here out of the Fox 12 Oregon newsroom. I like to remind everybody that we start every weekday at 1 o'clock. We go throughout the afternoon and we cover a wide range of topics here on this show, including breaking news. If that were to occur, this would also be the place to go. Right now, we are talking about, well, you see it right there on your screen, sea star wasting disease, something that probably a lot of people have heard that term before, have some familiarity maybe, but there have been some breakthroughs on this as far as discovering what actually caused this. We're going to get into the history of it. We're going to get into the research behind it, what it means, especially here off the Oregon coast. And to do that, we are joined right now by Dr. Bruce Menge from Oregon State University. And Doctor, thank you very much for joining us. You know, I know this is something that obviously you are very well versed in and with all of the research that you've been doing here over the years, but for everybody else out there who may not have the background or the complete familiarity, would you mind walking us through just, you know, really what this disease is and how this first came about as far as being noticed?
Yeah, I think a first point is that basically, at least on our coast, it's never been seen, it hadn't ever been seen up until about 2014. In 2013, we started getting reports of wasting disease occurring up in Washington and BC and in Southern California. It didn't hit Oregon until 2014. What it is it's a wasting disease, which means that basically it ultimately kills the sea stars that it affects. And the way it affects them is initially the symptoms might include twisting arms, eventually lesions form and holes might form in the body wall. They will lose arms as the disease progresses. Some of them become deflated. They basically just flatten out, lose all the internal liquid. Ultimately, they basically fall apart, and it's been described as dissolving into a puddle of goo.
And I mean, just thinking about that too, you know, dissolving there into a puddle of goo. I mean, just the imagery of that. And this is something, you know, once it was seen here off the Oregon coast, how widespread was it?
It occurred everywhere. Everywhere, you know, these animals live on rocky shores, and every rocky shore in Oregon and actually in California, Washington, and British Columbia, even up into Alaska, it occurred. It varied a little bit in how devastating it was. In Oregon, we saw mortality rates of 60 to 90% of the population's disappearing, dying. And in California, the rates were, I think, even higher. It affected all sea star species, as far as we know. Many of them in the subtidal below the low tide mark, also the ones that live in the intertidal region between the high and low tides.
That is a lot, yeah, of that's I mean a lot of species being affected right there, just of those sea stars. So when you look at that much devastation and that much loss of the sea stars, what effect did that have on the ecosystem there off of the Oregon coast, or just all up and down the West Coast?
Yeah, it depends on whether you're talking. So the two main species that were affected were an animal called the sunflower star, which is a many-armed, large sea star that lives in the subtidal and kelp beds and other subtidal areas. In the intertidal, it was the ochre star, which was most severely affected.
Oh, sorry, that's just noise in the background. I apologize. That's here in the newsroom.
Okay. And with the sunflower star, they basically were extirpated from most areas. It was very rare to see them in the environment. Up until recently, we started seeing a few. And that's like now 11 years after 11 to 12 years after the disease hit. With the ochre star, it was completely different. They were wiped out. The adults, the big ones, were wiped out in that first year. And in the following year, we started seeing huge numbers of little ones showing up, baby sea stars. This was also unprecedented. We'd never seen this before. It occurred at varying densities in sites in Oregon, but most sites had lots of these little ones. The problem is that the little ones can't do the same things that the big ones do. And as a consequence, uh, we expected to see mussels become more abundant lower on the shore where they normally don't occur very much. We did see that to some extent, but not as much as we thought we would. In the subtitle, um, the sunflower star is a major predator of sea urchins, as people probably know. And sea urchins eat algae. And among those algae are kelps. And what happened was, at least it was related to the loss of the sunflower star, was population explosions of the sea urchins and great reductions in kelp. This especially happened in Northern California. It's happening in Oregon as we speak. It happened more slowly here, but the kelp beds have suffered severely, especially down in southern Oregon.
And so that's something that can have a wide-ranging effect there too, losing those kelp forests essentially off of the coast because of that, because of the sea urchins. So let's going from there to go ahead. Sorry.
Well, no, go ahead.
Well, going from there, talking about that, just this expansive sea urchins and just how that's changing. When you look at for the starfish and what's happening now, in any kind of recovery, have we seen any amount of recovery that's been able to help out with that, or are we a long ways away from being able to tackle that sea urchin problem?
Well, again, it differs between the subtitle and the intertitle. In the subtitle, basically, we're seeing a few of the sunflower stars, but not enough to make a difference. So at the moment, the only activity that's going on with those is to try to raise them in laboratories and then release them into the environment. The problem is that wasting is still occurring at a much lower level than it was in 2013 and 14, but it's still there in all populations, including the ochre star. At the now and for the foreseeable future, it's unlikely that the sunflower star will be able to begin preying very heavily on sea urchins. In the intertidal, we've seen recovery of some populations, but not all. The ochre star it takes about 7 years for them to grow up from a little tiny sea star up to an adult size. And we're seeing that happening more and more, but there are still probably about half the populations that we follow that haven't fully recovered. So their influence as a predator in the system is still relatively weak compared to what it was before.
Can you tell us about this discovery, or at least this research and understanding of what the actual cause of sea star wasting disease was or is, and why that's so important?
Yeah, so the original idea was that it was a virus, but the research on that has since been abandoned. It wasn't the actual pathogen. This recent discovery is really exciting because they have targeted a single species of bacteria, which their experiments are pretty convincing that is the factor that killed off the sunflower stars. They did a whole bunch of different kinds of experiments using live animals, and the results were pretty strong. You're probably going to ask me what the next step is, and the next step is that now that we know that kills sunflower stars, we need to find out if it also kills others. And I've talked to the lead author on that research, and she says that that's one of the things that they're going to be pursuing is looking at other sea stars.
So looking at that and trying to see if that same that can be extrapolated out to these other sea stars. Is this something to where you potentially we could see a cure for this somehow for starfish to eliminate this bacteria that's causing all of these issues?
Yeah, I mean that one avenue of research would be to look at the bacterium, and it can be cultured apparently. What that means is that we could get some insights into what factors might control it. That'll be difficult though, because this is the ocean we're talking about, and presumably this bacterium is dispersed by ocean currents, waves, and so forth, and controlling things like that in the ocean is a very different prospect from what we do on land with pathogens that we have closer contact with and can and study more closely. But it's possible to look at that in conjunction with the sea stars, and look, for example, for genetic strains in the sea stars that might be resistant. So that would be one thing to look at as well.
When you look at this for the bigger picture for just the ocean ecosystem, I guess, say here off of the Oregon coast, we'll go with that. When you look at this discovery in the picture of the Oregon ecosystem off the Oregon coast there, how important is this for people to understand this discovery?
Well, I think it's important because this wasting disease has been found in areas other than our coast. It's been found in the New England region, and there was some recent word of mouth information from Florida that sea stars in Florida seem to be suffering this disease. So, we need to find out if this is the same pathogen down there, if it's this Vibrio that is killing those animals, or if it's a different one. So in terms of why this is important to understand, we need to know the threats that our ocean ecosystems face, and increasing disease is certainly one of these. And the first step is to figure out, what's going on, to understand what's happening, to identify the major characters before any possible mitigation strategies could be developed.
And that's kind of the next step then, is working through that, as you mentioned, culturing that bacterium and trying to figure out more about what it is and whether it's affecting those other starfish as well.
Exactly. Yeah.
Well, anything else that you think is important for people to know about this?
Well, the attraction of natural environments that have these sea stars in them, that's actually one of the big appeals to human populations. There are many, many people that really like and actually get excited going out onto the shore and seeing all these creatures that you don't normally see in daily life. And that's true for people everywhere, including ones that are not on the coast. So trying to retain these systems in something close to their natural or native state is, I think, an important societal need.
Yeah, that makes perfect sense. I mean, I can say for myself, I like, as you mentioned, see something you don't see in your normal daily life, but it's really important to have all of that protected. And and this research will hopefully help to protect some of those starfish and figure out what's going on there to try to mitigate some of that, as you mentioned. Well, Doctor, thank you very much, for having time to talk to us too and walk through this and just explain it a little bit more as far as what's going on there and why this is so important to know. And, thank you for all that you do as well, with all of this research and really finding out a little bit more about this. I really appreciate your time.
Oh, you're very welcome, and thank you for the opportunity to talk to you.
Yeah, thank you. And for everybody watching too, this is Fox 12 Now. We are live streaming here out of the Fox 12 Oregon newsroom. We have more coming up here throughout the afternoon. So if you're watching live, I'll be back in about 10 minutes or so, and you can join me then. And as always, download that Fox 12 Oregon app. You can watch live. You can watch these segments after the fact as well. But thanks for joining us. I'll talk to you soon. I'm Greg Nibbler. This is Fox 12 Now.